So welcome to this latest video on 162 Maths, and in this video we'll be going over the AQA GCSE Maths past paper of June 2023, High Paper 3, which is a calculator paper. Now before we get started working through the paper, just a reminder that a link to the paper and a question breakdown is available on the description below, and I'll also include a link to the 162 Maths contents page, which gives you easy access to other exam paper walkthroughs along with lessons that go through the topics in greater detail, topic tests and audits, which I strongly recommend you have a go at, particularly if you're revising for your final GCSEs. So let's get started on question 1. So question 1 reads that the line with the equation of y equals 2x plus 7 intersects the y-axis at A. Complete the coordinates for A. Now if you know y equals mx plus c, then the c part is basically where it crosses the y-intercept. So here you can see that the c is going to be 7. So here our y-intercept is going to be 7. For question 2, it says write down a fraction equivalent to 1.875. So here if I write 1.875 over 1, then for this all I then need to remember is I can't write decimals in a fraction. So if I multiply both the top and the bottom by 1,000, and the reason why I'm multiplying by 1,000 is because I've got 3 numbers after the decimal point, so I need 3 zeros. That's going to be 1875 over 1,000. And then what you then want to do is potentially either write that fraction, because the question doesn't say give the fraction in its simplest form, so I could either leave the answer as 1875 over 1000, or I could write a simplified version, which with it being on the calculator, it simplifies to give me 15 over 8. So any of those two equivalent fractions would be fine for that one single mark. For question 3, it says solve 5x plus 11 equals 3x plus 19. Now when you've got a double-sided equation, you always want to take the smallest x over to the other side. So here I'm going to subtract 3x from both sides. And so 5x take away 3x equals 2x plus 11. And then all that's left for me on the right hand side is the 19. Then from this we want to try and get x by itself. So first eliminate the 11, so that gives me 2x is equal to 19 minus 11, which is 8, and then divide by 2, which then leaves me with x equals 4, or I just write 4 as the x equals already written for me. Moving on to question 4, it says that a map has a scale of 1 to 5,000. How many meters are represented by the length of 4.5 centimeters on a map? So here if I have 4.5, then what I've got done is multiply that left hand side number by 4.5. So I need to do the same with the right hand side number. Now remembering this is on a calculator paper, so if I just do 4.5 multiplied by 5,000, I get an answer of 22500. Now for this, what we want to try and do is to write this in meters. So 4.5 centimeters is the equivalent of 22,500 centimeters, and it's this that I then need to convert into meters. So to convert centimeters into meters, all I need to do is divide by 100. So 22500 divided by 100 gives me an answer of 225. Moving on to question 5, it says the number of hedgehogs in England is expected to reduce by 4% each year. Assume there are now 1 million hedgehogs in England. Work out the expected number of hedgehogs in England after 5 years. Now this question here is a compound interest question. So here our original amount is 1 million. So I multiply that by a reduction of 4%. So remember that we always start with 100%, take away 4%, which equals 96%, and that as a decimal is 0.96. So I'm going to multiply that by 0.96, and I raise it to the power of how much time I'm wanting, which in this case is 5. So if I type that all into my calculator, making sure I've got the right number of zeros, and to the power of 5, I get an answer of 815372.7. Now obviously we can't have 0.7 of a hedgehog, so here the answer is 815373. I'm going to round up or round down, it's entirely up to you which one you want to do. I'm going to round down actually, because we can't have 0.7 of a hedgehog, and there is my answer. And in the mark scheme, they would accept any answer if you've done it manually, because you could just reduce it by 4 years each time. They would accept any answer between 800,000 to 820,000. So any of those answers would be fine, but that's the answer I give with you working out that I've done. Now moving on to question 6, it says here is cuboid A. Cuboid B is made up from 2 lots of cuboid A, and it says that the volume of A to the volume of B is in the ratio of 1 to 2. Matthew says the surface area of A to the surface area of B must be 1 to 2 because B is 2 lots of A. Is Matthew correct? And again, if you've watched any of my videos, I really don't like the way that they set these questions out. I would much prefer them to give you your working out space first and then come to a conclusion, rather than giving your conclusion and then proving whether it's true or false. So let's first of all have a look at working out the surface area of both those two. Now, so the surface area, now remember that the surface area is basically the area of all the faces together. Now if we look at the surface area of A, then that's going to give us a surface area of 6. Then the surface area of B is going to be 1, 2, 3, 4, 5, 6, and then on the other side 7, 8, 9, 10. So then the surface area of A to the surface area of B is going to, in the ratio of 6 to 10, which simplifies to be 3 to 5, which is not 1 to 2. So therefore the box we need to tick is going to be no, and this here would be my working out. Moving on to question 7a, it says complete the table of values for y equals x squared plus 2x. So for this, all we need to do is swap the x value in the table with the x in the formula. So to work out this number here, I'm going to do minus 2, and I'm going to put it in brackets because it's a negative number, squared plus 2 lots of minus 2. So I can just write 2 and then minus 2. Now if I type that all into my calculator, I get an answer of 0. And then if I, for this number here, I've got 1 squared plus 2 lots of 1, and that's going to give me an answer of 3. Then for 7b, it just says draw the graph of x squared plus 2x. So for this, all I need to do is plot the coordinates from the table of values. So at minus 3, it's at positive 3. At minus 2, it's at 0. At minus 1, it's at minus 1. At 0, it's at 0. And at 1, it's at 3. Then all that's left for me to then do is just carefully draw my parabola through those points, like so, and hopefully yours will be a lot neater than what I've just drawn there. But make sure that your curve does go through those points and that your it's a nice curve rather than a pointy one. Moving on to question 8, it says Ying has 2,450. She saves some money and gives the rest to her 4 brothers. The money saved to the money given to the brothers in the ratio of 2 to 5. She gives each of her 4 brothers the same amount. Does each brother receive more than £430? So let's first of all look at how much money she's giving. So here is our total amount, and this is the ratio that we need to share it among. So let's go for money saved to the money given. And so I've got 7 parts. So I'm going to do 2450 divided by 7, and that's going to give me the value of 1 part. So if I just type that into my calculator, I get an answer of £350. So here, with the ratio of 2 to 5, I multiply each of those numbers by 350, in which the money that's saved is going to be 700, and the money given is going to be 5 lots of 350, which is 1750. Now the next thing for me then to do is to know that she gives her 4 brothers the same amount. So what we need to do with this number is divide this by 4. So 1750 divided by 4 gives me an answer of 437.50 pence. So then going back to the original question was, does each brother receive £430? The question is yes, as 437.50 is greater than 430, and there is my reason for it. Moving on to question 9, it says the pie chart shows information about people at a fair during 3 days. There were 132 more people on Friday than there were on Thursday, and the question is asking us to work out the number of people on Saturday. So let's have a look at what this is then. So if we look at the angle difference between Friday and Thursday, we know that that is going to be 80 minus 25, which gives me 55 degrees. So that means that 55 degrees is equal to 132 people, and that's given by the information that's given here. So from this, what I can then do is work out what 1 degree is, and I'm going to do 132 divided by 55, which I don't think is going to be a nice number, but let's just stick it into the calculator, and it gives me an answer of 2.4. So 1 degree equals 2.4 people. Now the angle of Saturday is this angle here, and to work out that angle, all I need to do is 360 minus 80 minus 25, which if I type into the calculator, gives me an answer of 255. So that's for Saturday. And so that's 255. So the number of people then is going to be 255 multiplied by 2.4. And if I type that into my calculator, I get an answer of 612 people. And there's my answer. Moving on to question 10, it says use trigonometry to work out the value of x. Now when you're doing SOHCAHTOA, which this is because we've got a right angle triangle, first thing we want to do is label the triangle. So here is my theta, this therefore is going to be my opposite, and this length here is going to be my adjacent. So which trig ratio uses O and H? Well, that's going to be tan. So if I write down the formula, so tan theta equals O over H, I can then substitute the values in. So what I've got is I've got tan 58 equals x over 46. Now to get x by itself, all I need to do is take the 46 and multiply it. So 46 multiplied by tan 58. And if I type that all into my calculator, I get an answer of 73.61538834. Now, a question I always get asked is, if it doesn't specify how to round the answer up, what do I round it up to? If it doesn't specify, you can round it up to whatever you like. So if your rounding is a bit sketchy, you can just simply copy the answer off your calculator. But I would always say that depending on what units are used, always go one extra. So here, the length is of the length given with is rounded to the nearest centimetre, you'd imagine, potentially. So I'm going to round this number up to 1 decimal place. But just note that if your rounding is incorrect, you will lose a mark. So there's always that risk. But again, I'm fairly comfortable with my rounding, so I'm going to leave it as 73.6. Moving on to question 11, it says Millie is estimating the value of 1 over the cube root of 8.34 all squared multiplied by 10.21. She rounds each decimal number to 1 sig fig, and for 11a it says work out Millie's estimate. You must show your working. So for this, what we want to do is we want to round up our two values that we have in the denominator. So here we've got 1 over. Now because we're cube rooting 8.34, we need to round this number up to the nearest cube number. Now if you think about what your cube numbers are, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. So round this number up to the nearest cube number is going to be 8. So that's going to be the cube root of 8 squared multiplied, and we round this number up to 1 sig fig, and that's going to be 10. Now another reason why we can also round that up is this number of 8.34 to 8 is because, again, also to round it up to 1 sig fig is also going to give us 8. But again, typically, if you've got an estimating and you are working with roots, you always want to round it to whatever square or nearest cube number it is for your own convenience. From this, we've got the cube root of 8, which is 2. So that's going to be 1 over 2 squared times 10. 2 squared is 4, so that's going to be 4 times 10. Which gives me an answer of 1 over 40. And again, I could give my decimal equivalent, so I could type that into my calculator, but I'm going to leave it as a fraction just because. Moving on to 11b, it says, Millie says, my estimate must be more than the exact value. Without working out the exact value, give a reason how she can know this. Well, the reason why we know it's going to be more is because we have used a smaller denominator. So the reason for this is because we, or should I say she, has rounded down each of the decimal numbers. And there we go. And therefore, we're going to have a smaller denominator, which therefore means that if the number is going to be bigger, then we're going to have a bigger denominator, which then gives us a smaller answer. Then moving on to question 12, it says, here is a bias spinner. In 12.8 says, Ali, Ben and Carrie want to know the probability of spinning red on this bias spinner. They each spin it and count how many times it lands on red and divide it by the total number of spins. Ali says that I spun the red the most times. Ben says that I spun the spinner the most times. And Carrie says my relative frequency of red is 0.25. Who had the best estimate for the probability of spinning red? And give your answer why. And for this particular question, the correct answer is going to be Ben. And the reason for that is because the more trials equals the more accurate relative frequency. So something along those lines would be absolutely fine, but the correct answer you want to give is Ben, and the reason for that is because to get the most accurate answers you want to do the experiment the most number of times. Then moving on to 12b, it says Dev spins the spinner 80 times. He says that my relative frequency of red is 0.185. Give a reason why his relative frequency must be wrong. So for the reason for this is, well, because if I then do 80 multiplied by 0.185, and I'll type that into my calculator, it gives me an answer of 14.8 times, which this must be a whole number because it's the number of times in which it spun. So that's why Dev is wrong in the fact that he spun it 80 times. It then says Elena spins the spinner 125 times. The relative frequency of red is 0.32. Work out how many times the spinner landed on green. So if we first of all work out red, and that's going to be 0.32 multiplied by 125. That's going to give me an answer of, and type that into my calculator, gives me an answer of 40. So therefore, green is going to be 125 minus 40, which gives me an answer of 85. Then moving on to question 13, it says Charlie is driving 293 miles home. He leaves at 9 a.m, travels the first 176 miles at an average speed of 48 miles per hour and drives the rest of the way at an average speed of 65 miles per hour. Will he be home for 2:30 p.m? And it says you must show you're working out. So the first thing we need to do is recognize that there's two stages to the journey. We're going to call it A and B. Now, in order to do this, what we need to do is work out the time for A, which is the bit that's moving out. Now, for this, we need to use distance, speed, time. So we get the old triangle out. So here, the time of A is going to be the distance multiplied by the speed. So T equals D divided by speed. And so that's going to be 176 divided by 48. And if I type that into my calculator, I get an answer of 3 2/3 of an hour, which 2/3 of an hour is 3 hours and 40 minutes. Now, again, if you're not sure about converting fractions into minutes. If I just multiply that bit there by 60, not 40, it should give me the 40 minutes, which it does. Then moving on to the bit of the next stage. So we know that the rest of the journey, so the distance of B is going to be, well, we know that the total distance is 293. The first part of A was 176, so it's 293 minus 176. And if I type that into my calculator, 293 minus 176 gives me an answer of 117. So it's 117 miles. So then to work out the time of B, I use the same formula of distance divided by speed. So it's 117 divided by 65. And that gives me 1.8 hours. Now again, to get that into hours and minutes, if I multiply that by 0.8 by 60, I get 1 hour and 48 minutes. I don't know what I've written there, so let me just get rid of that. 1 hour and 48 minutes. So from this, what you can then do is work out the total time, which is 3 hours, 40 minutes plus 1 hour and 48 minutes. And again, there's a couple of things you could do to work that. You could either work it out manually or you could use your calculator. To show you how to do it on the calculator, let's just do this. So you should, if you've got a Casio calculator, you should have this button here. So if I type in 3 and then 40 and then press that again, I've got 0 seconds. Make sure you press it again. Plus 1 hour and 48 minutes and 0 seconds. Press equals, and it gives me a total time of 5 hours and let me just go back to the calculation, 28 minutes. So if I then add that to the start time, which was 9 a.m. so 9 a.m. plus 5 hours and 28 minutes is going to take me from 9, 10, 11, 12, 13, 14. So it's going to be at 14:28. So the question's asking, will they be home for 2:30 p.m? The answer is going to be a resounding yes. And that's going to be by 2 minutes. Moving on to question 14, it says Kieran paid income tax and national insurance on her annual salary. It says for the income tax, it's 0% on the first 12,540 on her annual salary and 20% of the rest of her annual salary. And for national insurance, it's 0% on the first 9,880 of her annual salary and then 13.25% of the rest of her annual salary. Kieran paid 5,186 income tax, and the question's asking how much in national interest did she pay. Right, so the first thing for this particular question is we want to work out what her total annual salary is. Now looking at income tax, basically the 5,186, if I can write it, which I cannot, so 5,186 refers to the income tax. Now for this, what we need to do is that basically equates for 20% of the rest of her salary. So for this we've got one. If we know that 20% is 5,186, then 100% is therefore going to be, well, if we've multiplied from 20% to get from 100%, we times by 5. So if we times 5,186 by 5, 5,186 multiplied by 5 gives me a total of 25930. Now that is the bit that's been charged income tax, but then we need to add 12,570, so a total annual salary is going to be 12570 because that's the untaxable element plus 25,930. So a total annual salary is going to be a value of 38,500 500. Now from this, what we can then do is use this information now to work out how much national insurance she's going to pay. So the national insurance, well, we know that it says that the first 9,800 is going to be tax-free. So 38500 minus 9880 is going to give me an answer of 28620. Now for this, what we then need to do is to work out 13.25% of this. So 13.25% of 28620. So we convert this into a decimal of means times 28620, and that is a 2. Type that into my calculator, which gives me an answer of 3,792 and 15 pence, and there is my answer for that one. Moving on to question 15, it says 180 runners started a marathon. Some of the runners did not complete it. The histogram represents the times of runners who did complete the marathon. How many runners did not complete the marathon? So for this particular question, what we need to do is we need to work out the frequency of each of the bars. Now for this, what we need to do is work out the area of each bar. So for this, the area equals the frequency, which is the main property of a histogram. So this bar here, I work it out to be, so splitting this up, I work out that to be 0.6, 0.7, that's going to be 0.8. So it's 0.8 multiplied by the width, in which we use the scale, which is 20. This bar here, I work out to be 1.8 multiplied by 20 again. This bar here is 1.2, and that's multiplied by 40. This bar here is going to be 0.7 multiplied by 40, and this last bar is, I work it out to be 0.4 is the height multiplied by 60. So working out the bar of each of those, so for this bar, if I just label this A, B, C, D and E, so the frequencies of A is going to be 0.8 times 20, so type that into my calculator, I get 16. For B, it's going to be 1.8 multiplied by 20, which is 36. For C, I get 1.2 multiplied by 40, which is 48. For D, 0.7 times 40, which is 28. And for E, 0.4 times 60 gives me 24. So then working out the total is just adding those numbers up. I get an answer of 152. So that's the number that completed the marathon. But the question is asking how many did not complete the marathon. So we know from the question that 180 runners started the marathon. So it's going to be 180 minus 152, which gives me an answer of 28. Moving on to question 15, B, it says the table shows information about runners who did not complete the marathon, and the question is asking us to draw a box plot to represent the data. Now to draw a box plot, we need the smallest value, we need the greatest value, we need the lower quartile, the median, and we need the upper quartile. Now to work out the upper quartile, which is information that's not been given, that's basically the lower quartile plus the interquartile range. So here we've got the lower quartile, which is 11, plus 9, which equals 20. So the upper quartile is 20. So if I just scroll down a little bit, I can just do onto the marking. Now hopefully yours will be a lot neater. So I've got 5, I've got the lower quartile 11, which is there, the median, which is at 18, which is there, then I've got the upper quartile, which is at 20, which is there, and the highest value, which is 23, which is there. And then all that's left for me to do is then turn this into a box plot, and again make sure you're using a ruler, not drawing it freehand like me, but these values should be 5, 12, 18, 20 and 23. Moving on to question 16, it says that this is a right angle triangle. A is 16 centimeters. The ratio of A to C is 4 to 5. And the question is asking us to work out the area of the triangle. Now, to work out the area of the triangle, it's going to be A times B divided by 2. The base times height divided by 2. So let's first of all just work out what the lengths are. So A is going to be 16 because we know that because it's written here. Then from this, I can then work out what C is. So A equals 16 centimeters, which equals 4 parts. So that means then that one part is going to be 16 divided by 4, which is 4. So therefore 5 parts is going to be 4 times 5, which is 20. So that means that C is going to be 20. Now to work out B, what we need to do is use Pythagoras' theorem. So B squared is equal to C squared minus A squared. So B squared is going to be equal to 20 squared minus 16 squared. And typing that into my calculator, I get an answer of 140. So B squared equals 144. So therefore B equals 12. And so to work out the area, so therefore the area using this formula here is going to be A, which is 16, times B, which is 12, divided by 2. So 16 times 12 divided by 2 gives me an answer of 96 centimetre squared. Moving on to question 17, it says solve, and we've got this algebraic fraction. Now with this, what we need to do is we can see two fractions, and we need to try and make the denominators the same. So to make a common denominator, we look at a common multiple of 2 and 5, which is going to be 10. So I'm going to multiply this first fraction by 5 over 5 and the second fraction by 2 over 2. So what that then becomes is 5 lots of x plus 8 over 10 plus 2 lots of 9 minus x over 10, and that all equals 4. Then what I can do is expand the brackets. So I've got 5x plus 40 plus 18 minus 2x, and that's all over 10. Don't know why I'm 20. Be careful of that because that's going to be a common mistake. Equals 4. If I take the 10 over by multiplying by 10, that disappears, and simplifying the expression. So here I've got 5x, take away 2x, which is 3x. 40 plus 18 is 58, and that equals 4 times 10, which is 40. Then take the 58 over to the other side by subtracting, so I'm left with 3x equals minus 18, and then from this I can then work out what x is. So it's going to be minus 18 divided by 3, which gives me an answer of minus 6. Moving on to question 18, it says that f of x equals x squared plus 6x, g of x equals 2x plus 4. Show that f g of x equals 4x squared plus 28x plus 40. So for this, what we need to do is we need to substitute g of x into wherever I see an x in f of x. So what this then becomes is fg of x is going to equal 2x plus 4 squared plus 6 lots of 2x plus 4. Now from this, what I then need to do is expand the brackets. Now this is going to be a double bracket, so that's 2x plus 4, 2x plus 4 plus 6 lots of 2x plus 4. Now expanding this out, what do I get? Well, I'm going to get 4x squared plus, and again I'm going to just jump a stage, but that basically is going to equal 16x plus 16 plus 12x plus 24. And if I simplify all of this by collecting the like terms, I get 4x squared. 16x plus 12x is 28x, and 16 plus 24 gives me 40, and that's what they wanted me to show. The next question then says for B, show that fg of x equals minus 5. So we want to solve this. So basically what this is, this bit here is part A. So what we know is that part A is 4x squared plus 28x plus 40 equals minus 5. Now to solve the quadratic, we need to make sure it's equal to 0. So 4x squared plus 28x plus 45 equals 0. Now from here, what we could do is you can use two ways of solving this. So to solve this, you can either do it by using brackets, so by factorising, or by using the quadratic formula. Now this does factorise, and again it's entirely up to you whether you use a quadratic formula or you do factorise. But if we do factorise it, it should give you 2x plus 5 and 2x plus 9 equals 0. And then if we solve this, either 2x plus 5 equals 0 or 2x plus 9 equals 0. So solving this, we get x equals minus 5 over 2. And solving this, we get x equals minus 9 over 2. So either we get an answer of minus 5 over 2 or minus 9 over 2, or you could write it as a decimal of minus 2.5 or minus 4.5. So any of those answers would be absolutely fine for the full 3 marks of that particular question. Moving on to question 19, it says two integers have a difference of 6. The integers are multiplied together and 9 is added. Prove algebraically that the result will always be a square number. So first of all, let's have a look at these two integers. Well, the two integers that have a difference of 6, so if we just call that x minus y equals 6. It says the integers are multiplied together, so that's xy, and 9 is added. And we all know that proves that the result is always a square number. Well, for this, if I first of all take this and I rearrange it, so if we make x a subject, then what I end up with is 6 plus y, or I could write it as y plus 6. So that's what x equals. Now, if I substitute x for that expression, so what I end up with is y plus 6 multiplied by y plus 9. And then let's simplify this. So we get y squared plus 6y plus 9. And then I factorise this, in which I get y plus 3, y plus 3, which ultimately becomes y plus 3 squared. And there we've proved that it's always going to be a square number for whatever value of y is, because when you add 3 and then square it, it's always going to give you a y answer. A squared answer, I should say. Moving on to question 12.8, it says Sunil thinks that E and D are linked by the equation E equals 36 over D. The graph shows the values of D and E for the values of D between and inclusive of 2 and 6. It says choose one point of the graph to state if Sunil's equation is correct for that point. So let's have a look at this then. So if I just pick the most nicest point that I can see, so it doesn't really matter which one you're going to go for. So let's go for this point here. So at that point there, we've got a corner of 2, and I make that out to be 18. So here, if x equals 2, then we're going to get E equals 36 divided by 2, which equals 18. And as you can see, that point is correct. It then says for B that G is directly proportional to the square root of H when the ratio of G to H is 3 to 2 when H is 16. Work out the ratio of G to H when H is 100. So let's first of all take this first line here. So when you're doing direct proportion, you always want to write this down using math notation. So G is directly proportional to the square root of H. Now, if you've done direct proportion, the first thing we need to do is we need a set of values for H and G. So if I use this to begin with, so if G to H is in the ratio of 3 to 2, and we know that H is 16, then that means that 2 parts is 16. So if 2 parts equals 16, then 1 part is going to equal 8. So therefore 3 parts is going to be equal to 3 times 8, which is 24. So we know then that G equals 24. So then from this we can then work out the value. So G is equal to K root H. Then using the numbers of H equals 16 and G equals 24, we can then work out what K is. So 24 equals K multiplied by the square root of 16, which is 4. So 24 equals 4K. So K equals 6. So then the formula is g equals 6 the square root of h. Now the question is asking us to work out the ratio of g to h when h equals 100. So when g is also when h is 100, g is going to equal 6 lots of the square root of 100. So that's going to equal 6 times 10, which is 60. So then the ratio of g to h is in the ratio of 60 to 100, which if we then simplify gives us 6 to 10, which then gives us 3 to 5. Moving on to question 21, it says a solid shape is made from centimetre cubes. The front elevation and the side elevation of this shape are shown, and the question is asking us to work out the maximum possible number of cubes for this shape and the minimum number of cubes for this shape. Now for this, let's first of all, let me just zoom out. Now for this, you really need to be aware of your plans and elevation. So if I look at the minimum shape that this could be, so the minimum shape is going to look something like this, and do excuse my drawing skills, but it's going to look something like that. And that's the minimum set of cubes that we've got. So if I just label the sides, I've got 8, I've got 7, I've got 9, I've got 5. That means that this length here is going to be 3, this height here is going to be 2, that's going to be 1, that's going to be 11, this is going to be 9, and we go from there. So looking at the number of cubes, if I just work out what this part here is, this side wall is going to be, now that's a compound shape, so that's going to be 2 times 5 plus 7 times 8 and times the depth of 1, so that's going to be 10 plus 56, so that's 66, and then this wall here, which is 11 by 9 by 1, and that's going to be, so this bit here is 11 times 9 times 1, which is 99, and then adding those two things, those numbers together, I get a minimum value of 165. And then working out the maximum, well, the maximum, what this shape is going to look like is it's just going to look like one big chunky L. And so what I can do is work out the area of the L and multiply it by the width, which is 12. So looking at the area of this side elevation, that's going to be 3. So 3 times 7 is 21. 5 times 9 is 45. So this area here is going to be 45 plus 21, which gives me an answer of 66. So here the volume is going to be 66 multiplied by 12, which if I type that into my calculator gives me an answer of 792. So the maximum value is 792 and the minimum is 165. Now moving on to question 22, it says shape A and shape B are shown on the grid. Describe the single transformation that maps shape A to shape B. So what we're looking for is going from this shape to this shape. Now as you can see, we've got a change in shape, so it's going to be an enlargement. And as you can see, going from A to B, not only has it gone half in size, but it's also flipped. So the scale factor is going to be -1/2. Now the last thing for me to then find is to find the center of enlargement. Now how we do that is we join two corresponding points together, and where the two projection lines cross will be our center of enlargement. So here, if I just join these points together, just bear with me because this can be a little bit fiddly on the computer. And this will be a lot easier if you're doing it on paper with a ruler and a pencil. And I join those points up, And as you can see, my center of enlargement is at this point here. So the center is at coordinate 7, 4. And each of those bits would give me 1 mark. So to get 3 marks, I need to say that it's an enlargement, scale factor of -1/2, and a center at 7, 4. Moving on to question 23, it says that a boat sails 35 kilometers north from A to B. From B, the boat then sails to C and then back to A. Show that the distance of the boat sails from C to A is 79 kilometers to the nearest kilometer, and you must show your working. So A to C is basically this length here. Now for this, as you can see, we've got a non-right angle triangle. So for this, it's going to involve trig, and it's going to be using sort of advanced trig for this. Now we know what this angle here is, because that's going to be 100 because it's on a straight line. And so because we know 3 sides and an angle, we're going to be using the cosine rule. So the cosine rule is a squared equals b squared plus c squared minus 2 lots of bc cos a. So then substituting numbers in, this angle here is going to be my capital A, this is going to be little a, this is going to be b, and this is going to be c. So from this, substituting those values in, I've got x squared equals 65 squared plus 35 squared minus 2 lots of 65 times 35 times cos of 100. So typing that all into my calculator, I get 65 squared plus 35 squared minus 2 lots of b times 65 times 35 times cos 100, and I get a x squared value of 6240.9099208, and then square root that answer, and I get x squared equals 78.99429.858, which rounded up, that should be x not x squared, so let me just get rid of that, and that gives rounded up gives me 79 to the nearest whole number, and there is my answer for part A. For part B, it then says work out the bearing of A from C. So going back to this, the question what it's asking me to do is to work out what this angle here is, and so that there is my answer to part B. So for this, if I take the triangle out, well, let's first of all work this out. So if I just draw an imaginary line that, well, actually let me just do that a bit better. If I continue this line of BC, then this line here is 80, and therefore this part here is going to be 100. And so then all that I need to do is I need to work out what this angle here is. Now I'm just going to call that y. So if I take that triangle, let's just draw that triangle out again. So let me just draw it out here. Again, apologies for that we worked out this angle. That's 100. This was 65. That was 35. And we worked out that this was 79. And it's this angle here that I'm wanting to find. Now to work out that, I need to use the sine rule. So if I just label this as angle A, this is going to be little a, and this is going to be my angle B, and this is going to be my little b. So using sine rule, we've got A, or should I say sine A, over 35 equals 79 over sine 100. Now we want to make sine A the subject, so we cross multiply. So I've got 79 sine A equals 35 sine 100. And let me just write that a little bit neater. Sine 100. And then we take the 79 over to the other side. So I've got sine A equals 35 sine 100 divided by 79. And then A is going to equal the inverse sine of that answer. So if I type that into my calculator, inverse sine of 35 sine 100 over 79, I get an answer of that A equals 25.828 blah blah blah. So this angle here is 25.8628 blah blah. Now if I go back to the diagram, now I know that this angle here is 25.868, and that answer on the calculator, and it's this angle that I need to calculate. So to work out that angle, it's going to be this total angle here, and that angle there is 100 plus 25.828, which is 125.868 rather. Then to work out this purple angle, this angle here is going to be 360 minus 125.868, which if I type that into my calculator gives me an answer of 234.132. Now remember, with bearings we always want to give it to the nearest degree, so it's going to be 234. And there we go.